Welcome back. As promised in the last video, we're going to talk a little bit about what factoring is and why we care about factoring polynomials. So on the left here I have the graph of a polynomial, and on the right I have its equation written out. So you'll notice I have f of x written out as x cubed minus 2x squared minus 5x plus 6. That's going to be kind of what we call the standard form of a polynomial. That's what we've seen before, just kind of this sum of terms that have that variable involved. And we're also going to see that I have it set equal to x plus 2 times x minus 1 times x minus 3. That's going to be what we consider the factored form of that polynomial. And each of those forms have their own benefits. So the reason that we might choose the factored form, or might want to get that factored form, is going to come back to what this graph looks like. So if you remember back when we talked about just linear functions, an important part of those was finding the x-intercept. Right? We asked all the time, what are the x and y intercepts? Well, it turns out that we care about that for polynomials as well. We want to be able to say, if I graphed this polynomial, where am I going to intersect that x-axis? So given the graph here, right, we can definitely pick them out from the graph. So we've got one intercept at -2, 0. We've got an intercept over here at 1, 0. And we've got a third intercept over here at 3, 0. We want to be able to have some method to find those intercepts without having to graph the polynomial. Graphing polynomials is actually quite a bit trickier than graphing those lines. And that's going to come back to that factored form. So you might actually notice that -2, that 1, and that 3, those are actually the x-intercepts of these three functions we have multiplied together to give us f of x. Right? The x-intercept of the function x plus 2, that's going to give us that root at -2 there. So that's kind of our goal when it comes to factoring. Factoring is going to help us find those intercepts. And we'll talk in a later video about how we know that the intercepts of those functions multiplied together end up giving us the intercepts of our original function. But for now, right, our goal is just to rewrite the polynomial as a product of polynomials with the lowest degree possible. We're kind of hoping, right? We're hopefully getting down to linear terms. It's not always going to be the case, but that's kind of our goal in the back of our head. It's just to get it down to that lowest degree. With that in mind, we're going to learn a method for factoring some polynomials. So this first method is what we call factoring by grouping. Factoring by grouping is going to be super helpful when we have polynomials maybe with just 4 terms. Is going to happen a lot. That's actually all the examples I have. But we can group with any number of terms in a polynomial when it comes down to it. So let's go into this first example. We're going to try and factor the polynomial 21xy minus 7y plus 6x minus 2. Now the grouping part of factoring by grouping is that I'm going to group together these first 2 terms. I'm going to group together these second 2 terms. And after I've done that, I'm going to find the greatest common factor of both of my groups. So in this first one, I'm looking for the greatest common factor of 21xy with -7y. Turns out the greatest common factor there is actually 7y. I'll do the same with those second 2 terms. The greatest common factor of 6x and -2 is going to be 2. And then we're going to use that skill we learned in the last video of pulling out the greatest common factor of polynomial terms. So I'm going to pull the 7y out of those first 2 terms. So if I take out that 7y, right, what I want to do is divide that 7y out of those 2 remaining terms, and that's going to leave me with a 3x minus 1. And I'm going to do the same exact thing with the next 2 terms. So I'll pull out that 2. What that's going to leave me with is, again, 3x minus 1. And that's super nifty, right? I've got this 3x minus 1 in both of the terms that I have remaining. So I can actually pull that 3x minus 1 out of both of those terms. Right? The same way I was able to pull the 7y out of 21xy and -7y, I can actually just pull the entirety of 3x minus 1 out of both of these. So if I take the 3x minus 1 out front, what am I left with? Well, if from this first term, I'm just left with a 7y. From that second term, I'm just left with that plus 2. And that's going to be the factored form of this polynomial, right? I now have actually gotten down to 2 nice linear terms. All right, let's go ahead and run through one more example. There's something a little bit tricky that can sometimes come up with this factoring by grouping. So for our next example, let's look at 72a squared b minus 8b plus 24a squared minus 24b squared. I'm going to do that same exact thing. I'm just going to go through, I'm going to group the first two, I'm going to group the second two, I'm going to find their greatest common factor. So the greatest common factor of those first two terms is 8b. The greatest common factor of those second two terms, since they don't have any of the variable part in common, it's actually just that 24. Okay, we're going to pull out that greatest common factor. So on the left here, I'll pull out that 8b. It's going to leave me with a 9a squared minus 1. On the right side, I'm going to pull out that 24. That'll leave me with an a squared minus b squared. But now I'm kind of trapped, right? Sure, I could pull out an 8 from both of these. Both of those terms have an 8 in common. But the thing in parentheses didn't turn out to be the same. And so that gets me really sort of trapped. I can't get down to a nice product the way I did the last time. So something that you sometimes need to do with these is that you need to rearrange the terms before you group them. So let's think about that a little bit critically. What we want to do is we want to try to maximize those greatest common factors. So what we want to do is we want to put together terms that look more similar to one another. So for instance, I see here that the 72a squared b and the 24a squared, they both have those a squared terms. So I'm going to put them together. That's going to increase that greatest common factor between my first two terms. So let's rearrange. We'll do 72a squared b, and then we'll add in the 24a squared. And then we'll have that minus 8b minus 24b squared. Okay, now we'll keep going through that same process. So let's group the first two, group that second two. The greatest common factor for those first two is going to be 24a squared. And then that greatest common factor for the second two is going to be 8b. Okay, so on the left, pulling out that 24a squared, that leaves behind a 3b plus 1. And on the right, we're going to take out that 8b. It's going to leave us with a negative 1 minus 3b. Now you'll notice with this approach, we didn't quite get down to exactly the same thing, right? It's not 3b plus 1 in both places. Both of the things in parentheses have a 3b and a 1, so we're actually super close. What would help us out is if neither of the terms in the second set of parentheses were negative. And we can actually take care of that pretty easily. We could pull out that negative 1 the same way we pulled out an 8b. Right, so I'll leave that 24a squared alone, times that 3b plus 1. I'm going to pull out a negative 1, so I'm actually going to turn this into a negative 8b. That's going to leave me behind as a 1 plus 3b. Then remember, addition can be done in any order. 3 plus 4 is the same as 4 plus 3. Similarly, 1 plus 3b and 3b plus 1 are going to be the same thing. So I could rewrite that to 24a squared times 3b plus 1 minus 8b times 3b plus 1. Now that I've got that thing in parentheses looking identical, now I can pull it out front. So I'll pull out front that 3b plus 1. What I'm left with from the left term is a 24a squared. What I'm left with from that right term, don't forget that negative, it's going to be a negative 8b. And that'll be our factored form for this polynomial. So it can get a little tricky with that rearranging, and maybe having to rearrange again the things inside the parentheses. But remember, the main goal is just take two terms, group them together, pull out their GCF, and see where you can go from there. In the next video, we'll talk about some more tools we can use for factoring these polynomials.